Okay, here's another example of an alkene in which there's another naming rule to consider. So if I number this alkene in either direction, whether it's from right to left, left to right, goes 1 to 6, right to left, is also 6. Now in both directions, the numbering for my alkene carbon is at position 3, going left to right, and it's also at position 3, going from right to left. Now the thing to consider here is, since both directions give me the same lowest carbon number for my alkene group, which is the highest priority, the next thing you want to take a look at is, are there any substituents? Which there is. There is the bromine halogen substituent here. So my next priority is to give the substituent the lowest possible carbon number. And I get the lowest possible carbon number moving from right to left, where I get the bromine at position 3 as opposed to left to right, where it is at position 4. So my correct numbering goes from right to left. My parent chain is 6 carbons. That's hex. Hexane is going to switch over to hexene. I'm going to place the number 3 in front to let me know that this is not located at position 1, but rather position 3, carbon number 3. And then in front of the parent name, I'm going to list out my one and only substituent. So 3 bromo 3 hexene. So that would be the name of this compound. Let's take a look at another naming rule that involves this, taking a look at priorities of substituents versus functional groups. All right, in this example, I have a cyclohexane ring, and I have a 1, 2, 3, 4 carbon branch extension coming off of that ring. Now what's unique about this straight branch coming off the cyclohexane ring is the double bond at the very end here. This double bond in alkene is going to take priority as a functional group over any alkane, straight chain, or for that matter, this 6 carbon cycloalkane in terms of establishing the parent. The parent chain is either going to be one of two places when it comes to double bonds. It's either going to be off the ring or on the ring. Here my double bond is off the ring, so the parent chain will be located off the ring. Give it the lowest possible carbon number, 1, 2, 3, 4. So here, my parent chain is a 4 carbon butene in which I've got this cyclohexane as a substituent. So cyclohexane being a substituent changes it over from cyclohexane, that's not the parent, to cyclohexyl. Remember, YL stands for substituent. You only use the ane ending for alkane-alkene parents. So 4 carbons is butene. The double bond is located on carbon 1, so I do not need to place the number 1 in front. It is implied to be on number 1 if I leave it as butene. Last thing to do is to name this substituent. The substituent is cyclohexyl. And lastly, name its position. It's located off of carbon number 4 on that butane parent. So the name of this compound is 4-cyclohexyl butene. If the double bond wasn't there and it was a alkane, then it's a 4-carbon chain off the ring versus a 6-carbon chain on the ring. That would lead to the cyclohexane being the parent. But because I have a alkene functionality, which is a higher priority than any alkane or cycloalkane, it's gonna be the source of my parent chain. What is the longest continuous carbon chain that I can get that contains the highest priority group?